It is my pleasure to welcome Trygve Karper up to the podium. He's giving the talk also a little bit of a different take on open. It's about liberating data, as far as I understand. I think his T-shirt tells the story. But Trygve, it's all yours.
So we're going to talk about analytics in asset-heavy industries. Asset-heavy industries means things like oil and gas, shipping, power and utilities, manufacturing, things with big, expensive equipment. So while you guys are breezing through life in a digital bliss with all modern technology and Facebook and ways of communicating and collaborating and whatnot, the industrial, asset-heavy industry is stuck in the Stone Ages. That's actually true. The gap is getting bigger and bigger. And we are going to talk here today why it's like that and what you can do about it and what I mean by that. So in fact, this gap is getting quite visible. So if you look through what has happened over the last years, since like 2001 until like 2008, you see that the world's biggest companies are changing in nature. Used to be oil companies and manufacturers and stuff like that. Today it is business-to-consumer companies living on data. And we all know this, right? We know this development. In fact, I think that the whole buzz around data science and analytics and stuff like that is fueled by this. So why is this? Why have they been so successful? We believe that that is because they use data. Like for instance, Facebook, they have a digital twin of you. They have a digital representation of you, which they use to leverage ads and generate ad revenue out of you. Amazon, same thing. They know more about you than any other online shops, and they convert much more buyers because they use data. So, but things are happening in the B2B world as well, and you are seeing things happening. Like, it is possible, right? Why is it like this? It's because it's impossible in asset-heavy industries. You cannot compete with business-to-consumer. No. You have examples, right? Where you actually have disruption using digital technologies and so on. And you have a very nice example disrupting the industry you thought was impossible to disrupt. If you were going out and you were saying, what is the most difficult industry to establish yourself in and actually succeed in getting a high market share? It has to be space, no? So, and they actually did that, right? Through error and trial and error, repeating, trying to reach a fantastically unbelievable goal, using the data and so on. SpaceX has managed to go from a joke to 2/3 market share in commercial space launches. So it's possible. It's not impossible to actually do something about this. So, are there money to be made? Well, according to McKinsey, there's tons of money to be made from digitizing this thing and increasing the efficiency and using digital technologies. So what's the reason? Don't we have the technologies? Yeah, sure we have the technologies. You have them from B2C world, and sure you have them. You have cloud stuff that would be good for industry. You have VR glasses, and you have it all. You have lots of technology that could really make industrial life just as much of a breeze as you have in your daily life. You have the algorithms and the models. They also exist as open source software even. So it's not due to a lack of technology or algorithms or something like that is making up this gap between B2C and B2B. So why? I don't know. When we go around at least and we talk to different companies about their digitalization and models and so on, all we hear are case study, pilot, proof of concept, test runs. And it's never operationalized. Never found any example. I'm sure there are examples, but we have not seen any of some analytics or something like that put into production and then scaled across the entire company or across an asset or anything. It's weird, no? We don't think it's because of algorithms. We think it's because of data. We think these things stay pilots and proof of concepts because they underestimate the value of data and data access. So we think it's all about the data, and so does Google, apparently. Like, we don't have better algorithms, we just have more data. They bought DeepMind and then published everything, right? Okay, so at least our take on this is that it's because of access to data. So let's start with that angle. If you go to an industrial company, what is it that generates data for them? Like, what do they interact with every day? What makes a big industrial giant go around in terms of software? Well, you have some systems that contain the sensor data, like some Windows software living in the basement, which is connected to some control systems, which records the sensor values and stores it there. And you can interact with that through some kind of thin client, well, desktop application where you can log in and see the values and so on. And you can, if you're really smart, also extract it through some sort of interface. Then you have maintenance systems. You log into some application, and well, you see something is wrong with a pump, you go to an application, desktop application, you log, hey, something is up with my pump. Can you please, someone take a look at it? Someone fixes it, logs into the same application and say, now I fixed it. It's probably a very good system, but the data stays in the system. So, and same with like HSC and ERP and so on and so on. So, if you go to one of the companies we analyzed, they used 100 systems like that to get around. Like, that was how their like everyday life goes around. They interact with 100 different data systems. So when you come with your fantastic data analytics model and you say, well, I can predict when your compressor is going to fail. I have the best compressor model in the world. And you ask this company, all I need is an integration to your sensor data and to your maintenance logs. These guys are going to say no. They don't care how good your model is. No, we already have like 5,000 active integrations, and our IT department, they don't do anything else than like maintain those connections. So for your one model, we are not going to let you have any more active integrations, point-to-point integrations. So that's the first problem, right? First problem is that you get a spaghetti of like point-wise integrations. It's impossible to scale that. Now, even if you got, they allowed you to like make a point integration to the sensor data and to the maintenance log, then you have the second problem. Which sensor data and which maintenance logs belong to the same equipment? It's terribly difficult. Like, for this company here, if you walked into their Pi, we did, into their Pi historian, you took a random sensor value and you said, where is this equipment located? It was just a 40% chance they could answer. Well, they could answer if they were calling around asking who, like they have some person somewhere in the company that knows. But the knowledge sits in humans, not in some computer system. Maybe, best case, in some Excel spreadsheet on some guy's laptop. How do you scale that? Okay, so you build your compressor model for one compressor. You call up the guy who knows how to connect this, and you get the connection. Well, you have spent now a long time. How do you scale that to all the other compressors? That's expensive. So those are kind of the two problems that needs to be solved at a fundamental level. Well, you could, of course, say, how about I just replace all the source systems? Like I make a new maintenance system that stores data in some way I specify and so on. That's going to take a long time. Yeah. So I wouldn't recommend that. So, as a consequence, what does a data scientist like me actually spend time on if I were to go to an industrial company and build a model? I would use 80 to 90% of my time finding the data. Calling up this guy, getting some data back, and trying to, okay, how does this connect to that? Calling some other guy, and cleaning some data, and going on like this. It's extremely inefficient. So Google estimates that you lose like 75% for this. Yeah. Of course, you get, at least when I worked with this, if you get very inconfident after a while. Which data actually belongs to what, and which sensor was this again, and do I really know that these two belongs together? Yeah, he told me so. Let's call him up again, and let's ask him, does it really like that, and so on. So you get a really increased risk of errors because there are many humans involved in like making up those connections. You get a very lengthy process, and of course, it costs money to use the time of a data scientist and some domain experts and so on, like repeatedly. So these projects are today very expensive. It's expensive to have someone build a predictive maintenance model for a compressor today. Very expensive. So here are some ways you could solve this. So the first is that you need to invest in some kind of data platform. Remove the spaghetti, right? Remove point-to-point integrations and have one integration to each source system instead of multiple. Right? So you have a horizontal data platform that takes the data from your source system and makes it available to applications on top. Right? So that means that you got just one point of integration and one point to maintain, not 5,000. That solves kind of the first. But secondly, that's not going to do it, right? You have to solve the second problem. So if you're going to do a predictive maintenance model, it's nice to have sensor values, but you should also know something about what it's measuring, right? Now we're talking about a machine that you can actually read out this automatically in some way without talking to people. So you need to know something about the sensor, what it's measuring, and so on. It would also be nice to know sort of which process it's in. Right? Which equipment is this sensor a part of? That's nice information to have. Or even more like, which process is the equipment again a part of? But you could go further. Maybe I could get the 3D model as well, so I know even more. I can know, say, I can correlate the physical distance between two sensors with the behavior. Right? Instead of like the process, like in terms of process, it could like be pipe flow, right? The pipe goes around here, and in terms of processes, they're far apart. But physically, they're close, and maybe then you have some kind of explanation for why the temperature are correlated, right? And then through like maintenance logs and so on, you could start building models that have much more knowledge, right? What does it mean in practice to do this? If you're one of these industrial companies, right? In reality, it entails that you build a data model for your company. I don't know if that's so clear. It's like to connect the dots really means that you have to standardize into some sort of data model for your company so that it's easily browsable. That you can say, for this pump, give me all the sensor values, all the technical documentation, the 3D models that are relevant, all the maintenance logs, events that are relevant, and so on. That is a data model you're really building. Thirdly, on top of this, you enable a thriving partner system where you can get in third-party vendors in an easy way. So this will also enable innovation, because earlier you had to pay a huge upfront cost. Well, without this data platform, it's a huge upfront cost for a startup company or a small company to try out giving you a solution, because they would start to write integrations to the source systems and integrating into your infrastructure. Right now, it's easier. You could just give them access and you can try them out. So you remove this huge upfront cost. So, fourth, and this is a big one. If you want to enable analytics at scale in an industrial company, you should solve the infrastructure problem for data scientists. It's a huge bar. Like, it's so much of what the data science consultancy does is software infrastructure. It's not the modeling, it's the software infrastructure. So first and foremost, you should have some kind of model management tool. You need that. And you should not be like saying to, like, you're not going to use one data science vendor. You're not going to talk to one data science consultancy and say, you build me everything. You don't do that, right? So you're going to go to one company that's good at GE equipment. Maybe GE, yeah? And you're going to say, how about you give me a solution for predictive maintenance there? And you're going to go to another vendor that's good at something else, and you're going to say, why did you build that? And if those two or those 50 uses separate systems to like model management and so on, that means that you will have to like keep a track of 50 systems. That's too much. So you should invest in like one kind of model management system where you can review all your models and see which models are running, how useful are they, how much do they cost, right? What's the status of them, and so on. One place. Otherwise, it's impossible to be a data scientist at your company. Like, we have 70 systems to monitor. And it should also be so easy that engineers and so on can like deploy some Python code themselves. So you can actually empower your own employees to do modeling without knowing a lot of programming and software engineering. This goes also for the second one. You should have some way of hosting functions, like Python functions. In that way, the engineer and some data analyst can automate workflows themselves inside your company. So today, I think a lot of workflow automation in these big industrial companies are consulting work. Like, you get some consultant to do it. Every month, please give me a report that goes through the historical data and counts the number of times my valve has been opened and closed. That's like a consulting gig today. That you could like write a Python function and deploy in some nice environment. You should invest in stuff like this. The other thing is, what if one engineer, makes something useful? We've seen that. Once engineers get an access to data and a way to do it, they start being creative, like develop their own stuff and stuff like that, and useful stuff. And how do you productize that? You don't even know about it. Maybe some friend of them wants to use it and so on. Like, it can spread. So they should have some kind of place to deploy that. So internal productizing of stuff that comes up is also enabled by such an environment. Lastly, and this is important, you need to provide some tools to speed up calculations. Like, for instance, say you want to do the FFT, a fast Fourier transform on hourly windows on raw data for the last 11 years. How long calculation is that on your laptop? 11, 12 hours. Easily. How long calculation is that in a Spark cluster? Some minutes, right? And then after those 11 hours, you figure out, nah, I think I want to do half-hour windows. That's new 11 hours, right? This trial and error is impossible without the correct infrastructure. So it's extremely important. And also to have some sort of proper model management framework for deploying new models and so on, like model versions to try out that and to keep track of what you've tried and not, and the deployment cycle. And finally, and this might be the most important thing you can do to enable data analytics in your company, you have to change how you work. And you actually have to give up control. So one thing is like here, it's like, identify use cases and work use case driven and like find, let's try to do that and that and that. But set also down some team, cross-functional team with an agile mentality that is autonomous. That's the difficult thing to drive into big companies. Like that team should be able to make changes without consulting 7 people up and down again. If not, then it won't work. It's too hard to make changes. So, thank you for your attention.
Do you have any questions while you're thinking about your question? Actually, so you brought up digital twin. Do you have a particular examples that you can sort of allude to where you actually have doing proof of concept on top of your platform? You know?
Well, we have such a data platform, that's true. And we have, among others, AKBP, which is a Norwegian company, live on our platform with all their operational data. I can do an example there. We participated in a hackathon like 2 weeks ago, a 2-day hackathon where we developed a virtual flow meter. So they don't have a flow metering on all their valves. They are routing one valve at a time through the flow meter. And then to do back calculation, like figuring out what a valve actually produces, they need some kind of way to do that. And the way they do it today is not that good. So we did a machine learning model that essentially just predicted the flow rates. And at the end of that hackathon, we deployed our model. It was live, running, available to all of AKBP in a nice infographic. And with 3 hours more work, you could scale it to all their wells. So I think that's kind of the example, that it's easy to operationalize. Right?
Is constructing the ontologies built on the folkologies of the subject matter experts and even a layer of IoT from the sensors then give you the capability to build an ontology that's translational, that it's translationally mapped between the different contexts?
I don't understand that.
An ontology?
Yeah, I know.
Yeah, the general semantics of the data. Because I think
so. You're talking about how to actually map the sources together.
Well, to be less disruptive, let them construct the folkology of the meanings of the data they use, and then incorporate that by knowing the structure of the business to map out, okay, well, this means this to this people, this means this to this people, and I don't have to make them all use the same language. They can use the language because I know the reference.
That's very, well, I think the company has to sort of think a bit about standardization, how they present things. And that's important to scale, and for your partner to be able to scale through customers as well, like to know sort of what to expect. So I think some sort of standardization is needed, unfortunately.
Okay.
I have a very simple question. Just to get some clarity on one of the models, like an application layer, service layer, data layer, the platform, then you have another tool set mapped to it, like Spark, the Databricks, ML Flow. How those tools mapped to the layers?
They're on top in a way. They are on top of the data layer. Yeah.
Okay, top of the data layer.
So they read from the data layer and they write back. And that exactly the same as any other third-party vendor or application or something or service would do.
Okay.
So,
All right. Thank you.
yeah.
Using that, I just want to get the map to the model and understand.
Yeah.
Okay, I think I don't see any other questions, so please join me in thanking Trygve again.